Dear audience, welcome to my YouTube channel. In today's video, I will talk about how to find the minimal value in an array using Nand2Tetris Assembly Language. The technique I'm going to use is TDD, Test-Driven Development. If you don't know what is a test-driven development, please watch my previous video. So let's implement those test cases in our .txt file first. Let's open up VS Code. New file. Here, ArrMin.txt. Let's insert the load command here. Load ArrMin.asm. This is our source code. So we don't need to manually load the source code every time. The test script will do it for us. The second command will be output file. Output file. Yeah, ArrMin.out. The third command is compare. We compare file. This is a ground truth, our ground truth file. Why doesn't it turn yellow? Compare file. Anyway, let's write ArrMin.cmp. This command should turn yellow. Oh yeah, compare to instead of compare file. The third command will be our output list. Let's specify some value. Let's use rem0 as a minimal value, the result minimal value, and array1 is what? Is a starting pointer, and array2 is a length of the array. Okay, let's write up the output list. First thing would be rem0. It's a decimal value, so use a %d. To make nice to padding, 6 significant number and 2 padding after. Similarly, rem1. Let's copy this over. For rem 1000, we need more significant bits to contain the name. Let's count how many bits we need. Rem 1000. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need 9 significant numbers. So let's change 6. 1000. Rem 1000 change 6 to 9. Let's cut this repeated process. You know what is happening. The next step is to initialize all input memory values. First thing is to set PC 0 because we want the program execute from the very beginning. Next thing is to set R0 as 0. The result where we're going to put the result. Third, let's set rem1, which is starting address of the array. So that's 1000. Next thing is the length of the array. which is 4. Then we need to put initial value of the array. Set RAM 1000 as 1. And RAM 1001 to be 2. Set RAM 1002 to be 3. Set RAM 1003 to be 4. Semicolon. The next thing is to use a repeat command. Let's repeat 200 times. Okay. Instead, we issue TikTok to let your assembly code to execute. Next thing is to recover the input values, because our method is going to modify R1 and R2. That's our first test case. 1, 2, 3, 4. You know what is happening here. Let's just cut the video short. The next step is to create the ground truth file, ArrMin.cmp. Let's do this vertical, move it lower, and we can read this ground truth according to our test script. Vertical bar. Two padding spaces. And RAM 0. Two padding spaces again. RAM 1. Two padding spaces. 视频太长，视频太长。Let's chop this tedious process away. Let's put our first test case, which is 1, 2 spaces, vertical bar. Remember that align this number to the right-hand side. 2 padding, vertical bar. Also, length is 4. The first element would be 1. One thing I would like to mention is for element 104, because of this test case, we only use 1000 to 103. So let's put all stars over here to indicate we don't care the result at those memory addresses. Use stars. Now we have done all the test cases. It's time to implement our assembly code. Let's create a new file, ArrMin.asm. Okay, before starting, what I would like to do is to calculate the termination condition. Instead of using array size 4, I would like to calculate the actual last element of the array. This is let's do this by adding 4 to the starting address 1000. Copy this code over. Let's see, 1000 plus 4 is 1004. But the last element is in 1003. We need to somehow consider the array index starting from 0. So we need to minus 1. Let's add a minus 1 here. Okay. So this becomes 103. We need to put an initial value for R0 because we are finding the minimal. So let's put the maximum possible number for 16 bits to its complement, which is 32767. Next thing is a main loop. Loop through each element in the array. Compare the current element to R0's value. If the current element is smaller, replace R0, and then increment R1 at the end of each loop. Until this R1 reaches R3, we terminate the loop. Copy it over, and let's use tab to make this looks nice. I think that's it. Let's run our code in the CPU emulator. CPU emulator.sh. Okay, let's load the test script. Where is that? ArrMin test script load. Okay, let's run it from beginning. So slow. Let's drag this to the fastest speed. It seems goes well. Oh, looks really nice. Let's wait it finish. Oh, comparison failure at line 9. Let's see what is happening. Switch to the output view. Line 9, what is count drag? At least we passed the first 8. Let's open up our output file in VS Code. Let's drag this ground truth to the ground. Yeah. Let's see what is happening. Oops, there's a mistake in our test file. Here should be minus 20,000 and here should be positive 32767. Let's run it again. Remember, each time we update the test file, we need to reload the script. Let's turn off the animation. This will be much faster. Let's see what happens. Oh, sucks. Still fail at line 9. The same problem? What is happening here? So it should be minus 20,000. But the output here is 1. Why 1 here? I think I got why. I think the overflow happens here. Because we are using subtraction, which is here. Use subtraction to compare the element and the R0. Let's see, who said R0 minus negative 20,000. So what happens? What's the result of this number? 32,367 minus 20,000. That is 52,767. Let's recall what is a maximum number for 16 bits to its complement number. Which is 2 to the power of 16 minus 1. Let's copy this equation here. Oh, 16k was wrong. 2 to the power 15, should be minus 1. Okay. This time it turns out 32,767. Definitely an overflow happens. Overflow! Exclamation mark. Yeah. Let's color this red. Where can red color? We need to somehow improve our code. Subtraction happens here, which may cause overflow. Overflow. Yeah, that's it. Let's think about how to improve our code. Yeah, let's do this. 分情况讨论. Consider it in different cases. R0 negative. If R0 is negative and R0 positive, R0 positive. Also, the element, if the element is negative, also element is positive. Instead of directly do subtraction, we jump to element negative. Let's see, R1, dereference R1, we get the element negative. We jump to that module from here. G if the element is greater than or equal to 0, we jump to element pos. Yeah. From here, element is already in D register. What do we need to do? Need to check R0. put R0 to D. If R0 is positive as well, we jump to that label, R0 pos, and D, JGE, I think. GGE. This will jump to R0 pos here. Let's write if both numbers are positive, then we do subtraction to prevent it from overflowing. Otherwise, if R0 is negative, do nothing, just skip, because a positive is naturally larger than the negative number. We don't even need to subtract. Pause, jump to here, and here we need to do subtraction. Just need to copy the code previously where we have subtraction to that module. Up to here, yeah. Copy and paste. Here, delete this one. Pause, jump to skip. Yeah, we need this part, skip. If the element is not less than the R0, we skip. Skip the swap process. Otherwise, jump to what's that label? I think it's update. Yeah. And unconditional jump. 0 GMP. Because we do subtraction in this submodule, we just delete the original subtraction from there. Instead of going to skip, let's jump to element is negative. Okay. Let's implement element negative. It should be very similar to element positive. Let's copy this over and do some modification accordingly. Here it is 0. We also compare 0. If it's positive, we should consider negative this time. Because if both numbers are negative, we do subtraction. Subtraction happen here. R0 neg. Then we do subtraction. Otherwise, skip. To change this less than to meet if the R0 is negative. It jumps here. So let's copy and paste. We don't even copy and paste because everything are the same. It jumped here and continue to execute R0 pause. Yeah, everything is the same. We don't need to make 2 copies. Yeah, that's it. Let's test it in CPU emulator. Reset and run. Oh, that's it of today's video. Thanks for watching.